All right, ladies and gentlemen, let's work today on a somewhat difficult concept, distance formula involving fractions. The reason this is difficult is because you have to work with these square roots. Now, I'm going to go through 10 of these in this video, and we'll just see how long it takes. First thing I'm going to do is split this paper in half, just so it's clear what problem I'm working on. Here's the first problem. First, let's get the distance formula written down up here at the top. Distance is equal to the square root of the sum of the squared differences between the x and y values. So I'll say here x2 minus x1 and y2 minus y1. So you've already got the square root there in the distance formula, and the common thing that happens when you have fractions is you end up working with these square roots. So let's just see where the problems take us. So our first problem, we've got -3 comma -1/5 and -2/3 comma 6/5. So let's just label them x1, y1, x2, y2. And let's write the distance formula, and we will fill in the information that we're given here. So we need a pretty big square root when we write these because it's the fractions. The square root of, and then we're going to build this template. All right, you always want to start by building the template out so you don't forget anything. It's always going to look like this before you begin. And then you just fill in your information. This is where x2 goes. That's -2/3. -2/3 minus, and then this is x1, and that's -3 minus -3. And over here, we've got y2, which is 6/5 minus y1, which is -1/5. So minus -1/5. Okay, so the very first thing we can do is recognize that we have a minus and negative. Okay, minus and negative. Inside the parentheses, we can make that a plus. So two minus signs become a plus sign. Okay, so that's what we're working with now. And we need to add these fractions inside. Okay, well, the problem right here is I've got a whole number. So I've got 3, and I need 3 to be a fraction with 3 in the denominator. So we remember here that 3 is really equal to 3/1. And if I want that to have a 3 in the denominator, I just multiply it by 3/3. And I have to multiply by 3/3 because I can only ever multiply a fraction by 1. And 3/3 reduces to 1. So 3 becomes, now multiply across the top and across the bottom, 9/3. So the very first thing we can do is go in here and replace that 3 with 9/3. And what else can we do in this step? We can add, because we have common denominators here in the second parentheses, we can add 6 and 1. 6 plus 1/5 would be 7/5. So that's what we're going to do next. I'll replace this 3 with 9/3, and I'll go ahead and combine these two fractions. So now D equals the square root of, open parentheses, negative 2/3 plus 9/3. Close parentheses, squared. Plus, open parentheses, and now 6/5 plus 1/5 is 7/5. 7/5. And that's still squared. Okay, so let's continue to work with this. Now we have common denominators here. We can do negative 2 plus 9 would be 7. So this becomes 7/3. So now D equals the square root of negative 2 plus 9 is positive 7. So 7/3 squared plus 7/5 squared. Okay, and now we need to think. Eventually, I will need to add these two fractions together. It would be beneficial if they had the same denominator. So right now I've got a 3 here and a 5 here. So I want to find the least common multiple between these two, and it's 15. So over here in our side work, I'll have 7/3, and I need to multiply that by 5/5. Okay, and that's going to equal 35/15. And then I've got 7/5, and I need to multiply that by 3/3. And that will give me 21/15. Okay, so I'm going to go back and rewrite these. D equals the square root of 7/3 has become 35/15. 35/15 squared plus, now I've turned 7/5 into 21/15. 21/15 squared. Well, here's a rule that you need to know. If I have A over B squared, that is equal to A squared over B squared. And that's a rule I'm going to exploit right now to get rid of these parentheses. I'm going to essentially distribute this squared term to the top and the bottom. So this will become 35 squared over 15 squared plus 21 squared over 15 squared. So we'll write that step. D equals the square root of 35 squared over 15 squared plus 21 squared over 15 squared. And now I recognize that I have a common denominator, okay? So I can actually add these together. I can say, I can't mix these because their bases are different, but I can say 35 squared plus 21 squared over 15 squared, all underneath the square root symbol. So I'll do that step here. D equals the square root of 35 squared plus 21 squared over 15 squared. Okay, now here's another rule you need to know. Okay, I'm going to run out of space here. The square root of A over B is equal to the square root of A over the square root of B. Okay, so that's the trick I'm going to use now. Instead of having all of this underneath the square root, I'll have square root of 35 squared plus 21 squared, big fraction bar, and then below I'll have square root of 15 squared. Right? So let me write that step. I think I can write this step here. D equals. Now I'll have two square roots. So the top square root will say 35 squared plus 21 squared over the square root of 15 squared. Now I did that for a very specific reason. Let me write this up here. The square root is really the second root. Okay? So there's a little trick. If I have the second root of A squared, like that, if you see those twos, that is equal to A, or plus or minus A, right? So let's exploit that right now. Let's exploit that principle. So I've got here the second root in the denominator of 15 squared, which means I can eliminate the square root entirely, because that's what happened here with A. So let me keep writing this, equals the square root of 35 squared plus 21 squared over just 15 now. Okay, so now what do we do? Well, now we actually need to square 35 and square 21 and add them together. So 35 times 35, and then 21 times 21. Okay, so two little math problems we need to do. 5 times 5 is 25. 3 times 5 is 15, plus 2 is 17. 5 times 3 is 15. Carry the 1. 3 times 3 is 9, plus 1 is 10. Bring down the 5. 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. 1. Okay, so I got 1225 right there. And now I'll do 21 times 21. 1 times 1 is 1. 2 times 1 is 2. 1 times 2 is 2. 2 times 2 is 4. So this is equal to 441. And now we have to add these two together, all right? 1225 plus 441. So I'll just stack them up like this. 5 plus 1 is 6. 2 plus 4 is 6. 2 plus 4 is 6. And then bring down the 1. So now I have in the numerator, I want to write this out here. We have the square root of 1,666 over 15. Ugh, I don't see any of that in my answer choices here. So I better keep going. Now, this is kind of the step like, what do I do now? Well, we can prime factor. 1,666. And that's exactly what we're going to do. Here's how you prime factor a number like that. 1,666. We know that it's got to be divisible by 2 because it's even. All right, so what is 1,666 divided by 2? Well, it looks like 833. And if I wanted to check that, I could go over here and say, what is 1,666 divided by 2? 2 goes into 16 8 times, no remainder. 2 goes into 6 3 times, no remainder. 2 goes into 6 3 times, no remainder. 833. So I put here 833. Now what? Well, we know this isn't divisible by 2 because it's odd. But the question is it divisible by 3? Well, we have to ask that question. The way you find out is you add the digits. If the digits add up to a number that's divisible by 3, then the whole thing is divisible by 3. So 833 is really 8 plus 3 plus 3. We're going to do that. 8 plus 3 is 11. 11 plus 3 is 14. Okay, so 14 is not divisible by 3. Therefore, 833 is not divisible by 3. All right, we just check another number. How about this? Do you think it's divisible by 4? I don't know. It seems unlikely. I'm going through in my head. I can't think of any multiples of 4 that end in a 3. There might be. I'm not saying there aren't. I'm just saying I can't think of any. It's not 5 because it doesn't end in a 0 or a 5. We could try 6. All right, I don't know, but I'm going to try 7. I'm going to try 7. So 833 divided by 7. I don't know if this will work. We'll see. 7 goes into 8 one time with 1 remainder. 7 goes into 13 one time. And then the distance between 13 and 7 is 6. So the remainder is 6. And now I've got, how many times does 7 go into 63? Well, that's 9. All right, so 7 times 119. Okay? Well, let's see. So now we have 119. And we need to try to break it down. It could be prime. Okay, I don't know. Let's see. So 119. What can that be broken down into? It's not divisible by 2 because it's odd. Is it divisible by 3? 1 plus 1 is 2. 2 plus 9 is 11. Okay, so it's not divisible by 3 because 11 isn't divisible by 3. So we have to try other numbers. Okay, and I actually can't think of any. Let's see here. Okay, so we've got to think. Let's double check our work. Is 833 really divisible by 7? 7 went into 8 one time, carry the 1. 7 went into 13 one time, carry the 6. 7 goes into 63 9 times. So it's 119 times 7. Okay. Let's see, is 119 divisible by 7? 7 goes into 11 one time. Okay. What is the remainder? 7 goes into 11 one time. and the remainder is 4. So now 7 goes into 49 7 times. Okay, so there it is. So you can break down 119 into 7 and 17. And here's the deal. We have arrived at prime numbers all around the edge. 2 times 7 times 7 times 17. Okay? So you can rewrite 166 as the product of these prime numbers. 2 times 7 times 7 times 17. And here's the key point. You could simplify that by rewriting this as 2 times 17 times 7 squared. And for square roots, it's this notation that's going to be useful to us. Remember, this all multiplies together to get 1,666. So now what do we do? Well, we're going to rewrite that square root of 1,666 as the square root of this product, 2 times 17 times 7 squared. And we can actually go ahead and combine 2 times 17 because they're both prime numbers. So, and there's not a multiple of them. There's not many of them. So we just multiply them back together. So the final thing that we'll put underneath the square root is 34 times 7 squared. So let me go back to my problem now. My problem was, let me bring it down. Remember, my problem was that I had this thing equal to the square root of 1,666 over 15. And I'm going to now rewrite that as the square root of 34 times 7 squared over 15. And now we can exploit a property, right? Remember, the square root of any number squared is just that number. So here's what I can do. There's another property of square roots that we can exploit here, which is that the square root of a times b is equal to the square root of a times the square root of b. So I'm going to exploit that property right here. I'm going to rewrite the square root of 34 times 7 squared as the square root of 34 times the square root of 7 squared. All right, so let me put that here, equals the square root of 34 times the square root of 7 squared over 15. And now for the final piece. Because I have the second root of a number squared, I can disappear the square root and just leave behind the number. All right, so here's what this looks like. This looks like, because the square root of 7 squared is just 7, I can rewrite this whole thing as 7 times the square root of 34 over 15. Okay? And there's no way to reduce this down any further. Because we use prime factoring, we can be sure of it. So this is the distance between those 2 points. Let's go back to our problem and see if that's one of our answers. 7 square root 34 over 15. And it is. It's number C. Okay? So like I said, I'm going to do these 10 problems. I went methodically and slow, which was good, so I didn't make any mistakes through that first problem, and it took 25 minutes to solve the problem. But remember, I was talking the whole time, and I was explaining what I had to do. And then down in here, we had to kind of guess and check. What are the divisors we need to use? And when you see these numbers, it's like, well, I don't know the multiples. I don't know the factors of 119 off the top of my head. So you kind of have to play with it. You have to guess. We got lucky there. We guessed 7. It worked. But you might have to do multiple little divisions like that before you find one that goes into it evenly. So that's how you do the first problem. Now, I'm just going to leave the mic running here, or I'm going to mute the mic and take a little break because that was a lot of work. And I'll come back here in a minute and do number 2. So I'll put time codes in this video so you can just jump to the problems. But I want to keep the video running so you know that I'm actually sitting here doing this. There's no cuts, there's no edits in this video. All right? So I'll be back soon. All right, well, I took a little break. Okay, minute. Let's get back at it. All right. So now we're going to find this distance. This is x1, y1, x2, y2. You ask yourself, why is this guy sitting here doing this? Well, here's why. I want to, for 2 reasons. I'm trying to teach this and teach the method, but I'm also trying to prove a point, which is you must have dedication to this. And you will only be able to do problems like this if you practice, practice, practice. So, I made up this worksheet and I have no idea what the answers are, right? They're not on this piece of paper. And you don't know this, but I don't have an answer key just sitting around. The answer key is actually beneath all these pages and I haven't looked at it. So I'm really not even sure that that's right. I'm pretty sure it is, right? But the whole point of this is not for me to show you how smart I am. It's to show you what is the process of mental activity that takes place in the human brain that gets you from this huge mess down to this simplified root, okay? The simplified answer. And that's really the point. It's really more to prove that it's possible to just sit here and work problems like this. And, when students say, oh, I don't want to do this work, I also want to prove a point that as a teacher, I don't believe that I should ask you to do anything that I don't want to do myself. So to sit here and do this marathon of activity after work, it's 5:20 p.m., worked all day. But to sit here and do this is very much like, what a student would do for homework. And there's nothing. It's fun. It's interesting to solve the puzzle, but it's also kind of a grind. And guys, work is a grind. So this is work. We're doing work. We'll feel good when we're done. Well, let's get to it. So we'll write out the distance. The distance is going to be equal to the square root I don't like that trailing off like that. Okay. Equal to the square root of, open parentheses, and now I need x2, 1/3, minus x1, 5/4, squared, plus, open parentheses, y2, 1/2, minus y1, 1/3, squared. Okay, so now we got to combine these, right? We got to find common denominators for everything. And we know that the common denominator for 3 and 4, the least common multiple, will be 12, right, between 3 and 4. So we'd have to multiply 1/3 times 4 over 4 and 5/4 times 3 over 3. All right, so we'll do that. Over here, 1/2 and 1/3, it's going to be 6. All right, so we'll multiply 1/2 times 3/3 and 1/3 times 2 halves. Right. So we're going to do that here, and then we do it. I'm not going to write it all out. So we're finding common denominators right now. So 1/3 times 4/4 would be 4, so open parentheses, and then it's 4/12 minus, then 5/4 times 3/3 would be 15/12 squared plus, open parentheses. Okay, 1/2 times 3/3 is 3/6 minus 1/3 times 2 halves is 2/6. And this is all squared. Well, now we can combine our fractions inside the parentheses. So d equals the square root of 4 minus 15 is negative 11 over 12, and that is squared, plus 3 minus 2 is 1, 1/6 squared. Now, remember what we did in the last problem. We need to find a common denominator between these two fractions now. So what is that common denominator? That would be 12. Right, so I would need to multiply this fraction by 2 over 2. Okay, so I'm going to do that in my head, okay, and then rewrite it. D equals square root of negative 11 over 12 squared plus 2 over 12 all squared. Now we're going to apply one of our laws of exponents, and that is when I've got a over b squared, that's equal to a squared over b squared. So let me rewrite this again. D equals the square root of negative 11 squared over 12 squared plus 2 squared over 12 squared. And now I notice I've got common denominators here, so I can combine everything like this. D equals the square root of negative 11 squared plus 2 squared over 12 squared. Right? And now I'm going to apply one of my rules about square roots, which is that the square root of a over b is equal to the square root of a over the square root of b. So I'm just going to put the numerator and denominator in their own square roots. The square root of negative 11 squared plus 2 squared over the square root of (12 squared). Okay? And now I've got to remember another rule, which is that the second root, or the square root of a number squared, is just that number. So here in the denominator, the square root of 12 squared is just 12. All right, so we will rewrite this. D equals the square root of negative 11 squared plus 2 squared over 12. And you say, man, you're just rewriting everything over and over again. Yeah, but each time we change one thing, right? And that makes it easy to spot an error if we make one. If you try to do a bunch of steps at once and you make a mistake and it all happened in your head somewhere and it's not on the paper, then it's hard to figure out what you did wrong. So that's why we do that. All right, now we can work on the numerator here. We're still working in here. I've got to do 11 times 11. Okay, so negative a number squared is going to be positive. So anything negative that's squared is going to come out positive. So negative 11 times negative 11 is going to be a positive number. Side work, haven't had to do much yet. 11 times 11. 1, 1, 1, 1. Right? So that's 1, 2, 1. 11 times 11 is 121. And 2 squared is 4. So go up here and say, what's 121 plus 4? And that's 1, 2, 5. All right? So now we can rewrite this. D equals the square root of 125 over 12. Okay? Well, now we got to break down 125. And what do I mean by breakdown? I said prime factor 125. So I need to prime factor 125 down into prime numbers. Right off the bat, people will say 5 times 25 is 125. Good. And 25 is 5 times 5. So I can rewrite 125 equals, 125 equals 5 times 5 times 5. And what I'm hoping to do is find two of them together. So I can, instead of writing 5 times 5 times 5, I can write 5 squared times 5. Every time I can get something squared like that, I can pull it out of the square root. All right, so let me go back here and just put an equal sign here. So now this is equal to the square root of, not 125, but 5 squared times 5. All over 12. And here's the thing. We can break up using this rule here. The square root of a times b is the square root of a times the square root of b. Right? We can use that rule right now. You say equals the square root of 5 squared times the square root of 5 all over 12. And remember that the square root of a number squared is just the number. So the square root of 5 squared is just 5. So I can simplify this down to just 5. So now my final answer is 5 square root 5 over 12. Okay? And that's my final answer. Let's see if it's in the answer choices. Ah, I love waiting till the end to look, right? There it is. All right, so we did 2, and that one didn't take as long. It took like 20 minutes. Or no, it was at 27, now it's at 41. So it took 14 minutes, 15 minutes, 14 to 15 minutes to solve that one. Not too bad, right? So do you get the idea of what we're trying to do here? We're trying to strategically manipulate the numbers. So I don't think there's a single task besides working with these fractions and square roots and stuff that teaches you more about how numbers are actually put together and how you can manipulate those numbers. Like we turned 125 into 5 squared times 5 to achieve a goal, you know? And so there was like a strategy there. I was trying to find that. So that is number 2. I'll let you take a look at number 3 and get started on it if you want to, or take a break. And here comes number 3. And I see right away I'm going to have to convert that mixed fraction into an improper fraction. But I'm going to take another little break, and I will be back shortly. All right, so we are back now, and I've got some coffee, very important ingredient to success in mathematics and teaching. So let's get back into this. We're on number 3, so I'll split the page down the middle. And we'll take a look here at this one. Right away, I've got to convert 3 1/4 into an improper fraction, and that would be 4 times 3 is 12, plus 1 is 13. So it's 13 fourths, 3 1/4, 13 fourths. So our coordinate pairs, and we could go ahead and convert this into 4 over 4, and this into negative 4 over 4. All right, just to get everything done. So let me just rewrite these coordinate pairs here as 13 fourths, comma, 4 fourths, and 5 fourths, comma, negative 4 fourths. All right, and let's label the points. X1, Y1. X2, Y2. And now we'll go into our distance formula and just plug these values in. So distance is going to equal the square root of, open parentheses, now I need x2 minus x1, 5 fourths minus 13 fourths squared plus y2 minus y1, negative 4 fourths, minus 5 fourths squared. Okay, so because we took that step in getting the common denominators, we can go ahead and subtract. 5 minus 13 is negative 8, and negative 4 minus 5 is negative 9. So I'll just rewrite this. D equals the square root of open parentheses. 5 minus 13 is negative 8. So negative 8 over 4 squared plus negative 9 over 4 squared. Okay? Now resist the temptation to simplify this fraction. Okay? Don't do that. Because you can't simplify this one down to a whole number. So we don't want to write negative 2 here. We want to leave it like a fraction. So now, because we have common denominators already, we can apply the rule where, remember the rule, is that A over B squared is equal to A squared over B squared. Right? And that's what we're going to do here to both of these fractions. To get rid of these big parentheses, we'll write D equals the square root of negative 8 squared over 4 squared plus negative 9 squared over 4 squared. Okay, and because we have still common denominators, we can combine these together. So d is equal to the square root of -8 squared plus -9 squared all over 4 squared. Okay? And now we're going to apply the rule that the square root of a over b is equal to the square root of a over the square root of b. Okay? So I'm going to break this up into 2 square roots. So d equals the square root of -8 squared plus -9 squared over the square root of 4 squared. And now I'll apply the rule that the square root of a squared is equal to a. And we'll leave out plus or minus a. We'll just say it's equal to a. And so that means that the square root of 4 squared is just 4. Okay? So now I'll rewrite this. D equals the square root of -8 squared plus -9 squared all over 4. So you see we're simplifying it. We've gone from this mess right here down to this. It's more manageable. So now we will turn these into their squares. So -8 squared is 64, -9 squared is 81. So D equals the square root of 64 plus 81 all over 4. Okay, well, what is 64 plus 81? 64 plus 81, 4 plus 1 is 5, 6 plus 8 is 14, 145. So now I'll rewrite the square root of 64 plus 81 as the square root of 145. D equals the square root of 145 over 4. Now I've got a prime factor, 145. I know it's divisible by 5 because it ends in a 5. So what is the other one, right? Well, 5 goes into 14 twice, and there's 4 as a remainder. 5 goes into 45 9 times. So 145 divided by 5 is 29. Okay? Is that right? Let me double check that. I don't trust my mental math. 5 goes into 14 twice. 2 times 5 is 10. 14 minus 10 is 4. Bring down the 5. 5 goes into 45 9 times. There it is. Okay, just checking. Just checking the math. So now we have to ask, can we break down 29? Well, I don't believe we can. Maybe we can. Let me think. We can't divide it by 3. We can't divide it by 4. We can't divide it by 5. We can't divide it by 6. It's not divisible by 7. So it's 13. No, 13 times 2 is 26. 14 times 2 is 28. 13 times 3, that's 39. So it's maybe 29 is prime. Maybe it isn't. I don't know. So we have to keep trying. Let's see here. I think it's prime. Maybe it's not prime. Try to think. Something that ends in a 9. It's a prime number. So I want to check my math. I'm just looking back over the problem to see if I made any mistakes. Yeah, I see the mistake. And I wanna absolutely die right now. So way back here, I made a mistake. Way back at the very beginning, I plugged in this value instead of 1. So this should have been 4 over 4 right here. I'm so stupid. Okay. This should have been 4 over 4. And that would have made this negative 8 over 4. Okay, so I found the error. We can fix it. We can fix it. All right, so let's go fix this. This should have been 4. And that means that negative 4 minus 4 is negative 8. And this 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 is negative 8. All right. So this should have been 64 plus 64. I'm sorry. So and I'll tell you, when these mistakes happen, it's almost instructive. I mean, obviously I shouldn't have made that dumb error, but checking, it would have been impossible to check the work if we hadn't shown all the work. So like as a case here, I want to show that, wow, we were able to go in and fix all of our work with just a little correcting tape. And now we're ready to proceed. So I need to do 64 plus 64. That was the error. So 4 plus 4 is 8. 6 plus 6 is 12, 128. So now I need the square root of 128. Much, much better. All right, so now let's break down 128. Right, so we break it down. And I know this is divisible by 2. And that would be 64. 64 is divisible by 2, and that would be 32. 32 is divisible by 2, and that would be 16. 16 is divisible by 2, and that would be 8. 8 is divisible by 2, and that would be 4. And 4 is divisible by 2, and that would be 2 times 2, like that. So now how many of these 2's do I have? 1, 2, 3, 4, 5, 6, 7. Okay? 2, 2, 3, 4, 5, 6, 7. All right, so let's double check that that's right. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And 64 times 2 is 128. All right? So here's how we can rewrite this. We can rewrite this as, like 2 squared times 2 squared times 2 squared times 2. Okay, so this is 2 squared, and this is 2 squared, and this is 2 squared. Okay? Times 2. Don't forget this guy right here. So now I'll rewrite this numerator here as d equals the square root of 2 squared times 2 squared times 2 squared times 2. Okay? So I'm thinking ahead here, and I'm going to go ahead and put 4. See, 4 is 2 times 2, so 4 is 2 squared. I'm going to put this as 2 squared for a reason, because I'm going to be able to cancel it here in a second. So how many of these 2's can I pull out of this thing? Well, remember, we can rewrite this as the product of square roots in the numerator. So d is equal to the square root of 2 squared times the square root of 2 squared times the square root of 2 squared times the square root of 2, all over 2 squared. Okay, so d equals, and now remember, the square root of 2 squared is just 2, so this becomes 2 and 2 and 2. So now I have 2 times 2 times 2 times the square root of 2. All over 2 squared. Okay? So now I'll say, well, 2 times 2 is 2 squared. So d is equal to 2 squared times 2 times the square root of 2. All over 2 squared. And now I can cancel out these 2 squareds. So now d is suddenly equal to 2 times the square root of 2. Let's see if that's an answer choice. And it is. So this was a rookie error right here. I wasn't paying attention. And I put in y1 when I should have put in I put in x2 for right here when I should have put in y1. I made a mistake. But then I went back and corrected it with the correcting tape, and we got back on our feet. All right, so sorry for that error, but this is the process. You make a mistake, go back and fix it. Keep going. All right, and you get back to this nice simple 2 square root 2. Okay? another break is in order. So we're on number 4. We'll take a break, come back. All right, so we're back now, and we will try to proceed without juvenile errors like that. It's really, this one I got to brush off. All right, it's like throwing an interception or something. Stupid. All right, so let's get back into this. We need to turn this into, for number 4, we need to turn this mixed fraction into an improper fraction. 2 times -1, or 2 times 1 plus 1. Don't worry about the negative sign. So 2 times 1 is 2, plus 1 is 3. So -1/2 is -3/2, right? And I can put 2 in terms of 2 by rewriting 2 as 4/2. So I'll just say, well, we're going to rewrite this as -3/2, comma, 4/2, close parentheses, and -5/4, comma, 5/3, close parentheses. Now, we've learned something from these last 3 problems. We've learned that all of these denominators need to be equal to one another. And that would really help us, you know? It would save us that step later. So we can go ahead and do that. The least common multiple of 2, 4, and 3 is going to be 12. So I need to multiply -3/2 by 6/6, 4/2 by 6/6, -5/4 by 3/3, and 5/3 by 4/4. Okay, so we'll just do that again. So these new coordinates will be, so -3 times 6 is -18 over 12, comma, and then 6 times 4 is 24, 24 over 12. And now I've got to multiply -5/4 by 3/3. And that's going to be 5 times 3 is -15. So -15 over 12, comma, and then I've got 5/3 times 4/4. That's 20/12. Okay, so now we'll label this x1, y1, x2, y2. And we will make sure when we put this in, we have put in the points correctly so we don't make that error again. Ugh, this is bothering me. Okay, so now d is equal to the square root of, open parentheses, and now I need x2, which is negative 15 over 12, minus x1, which is negative 18 over 12, close parentheses, squared. Can verify that that is x2 and that is x1, plus y2, here we go, I'll never make this mistake again. This is 20, famous last words, 20 over 12 minus y1, 24 over 12, squared. Okay, so we'll extend this guy out. Well, now that we got common denominators everywhere, we're going to be able to go ahead and work with this. Now, right here, I've got negative 15 twelfths minus negative 18 twelfths. Negative negative is a positive, so this is really a plus symbol, and this little negative sign can go away. Okay? And we can combine negative 15 and positive 18, and that would be positive 3. And over here, we can do 20 minus 24, and that would be negative 4. So D equals the square root of 3 twelfths squared plus negative 4 twelfths squared. And now I can bring these squared terms down and distribute them inside the parentheses. So D is equal to the square root of 3 squared over 12 squared plus negative 4 squared over 12 squared. Of course, I can now say 3 squared minus 4 squared over 12 squared. Okay, so D is equal to the square root of 3 squared minus 3 squared plus negative 4 squared over 12 squared. Okay, and this square root symbol came all the way down here. Now we can break the square roots up by numerator and denominator. So D equals, okay, and I'll do a numerator square root and a denominator square root. 3 squared plus negative 4 squared over square root of 12 squared. Now I can apply that principle about turning a square root of 12 squared into just 12. And I can also go ahead and say what's 3 squared is 9, and negative 4 squared is 16, and 9 plus 16 is 25. So I can rewrite this as D equals the square root of 25 over 12. Well, the square root of 25 is 5. So D equals 5 twelfths. And that's an irreducible fraction. I feel confident that that's right. And there it is. It was nice. It came out to a number like that instead of some crazy square root. So that is number 4. Okay. If I'm going to plow ahead, do number 5. Okay, so I've got to convert some mixed fractions here. This will be 7/6 and 10/9. So this is going to equal 3/2, comma, -7/6 and 10/9, comma, and let's go ahead and turn this into something. We'll do -9/9. -9/9. And now we got to find the common denominator here and fix all these fractions. So between 2, 6, and 9, the least common multiple is going to be 18. So I'll multiply 3/2 by 9/9, -7/6 by 3/3, and then 10/9 and -9/9 both by 2/2. So here comes the updated fractions. 3/2 times 9/9 is 27/18, comma, -7/6 times 3/3 is -21/18. And then 10/9 times 2/2 is 20/18. And -9/9 times 2/2 is -18/18. So now we got our fractions all set up. We can go into the distance formula now. D equals the square root of big square root. And now I should label the points x1, y1, x2, y2. So now I'm going to take the square root of, and I've got x2 minus x1, 20/18, minus x1, which is 27/18, squared, plus, and now y2 minus y1, that's -18/18, minus y1, which is minus -21/18, squared. Little thing I can do here, minus minus becomes a plus. And now I can combine these fractions together, simplify. So D is equal to the square root of 20 minus 27 is -7. -7/18 squared, plus -18 plus 21, +3/18. And of course, that whole thing is squared. So now What I'm doing right now is I'm just thinking about something. Okay, no, I'm not going to do that. I'm just going to keep going the way I've been going. D equals, and now what I'll do is distribute these squares into each term. So it's the square root of -7 squared over 18 squared plus 3 squared over 18 squared. Okay? And now I can combine. So D is equal to the square root of -7 squared plus 3 squared all over 18 squared. And now I can break this up by numerator and denominator with the square roots in both. So D is equal to the square root of -7 squared plus 3 squared all over the square root of 18 squared. Now I can apply that rule about the square root of a number squared is just the number. So D is equal to, and I can go ahead and turn this into 49 and this into 9. And 49 plus 9 is 58. So D is equal to the square root of 58 over 18. Now we'll break down 58. Okay, 58 divided by 2. 2 goes into 5 twice. 2 goes into 18 9 times, so 29. And that's a prime number. And that's what, when I saw that in the 2 problems ago, that's what made me start thinking I did something wrong. But in this problem, we were super careful, so I'm okay with that. So there's no way to really break this down. So it's not advantageous to us because we weren't able to find pairs of factors that we could turn into squares. So we're just going to leave it as 58. All right, so the answer is right there. This is irreducible. So we stop. Square root of 58 over 18. Right there. Okay. I feel like we can move on to number 6. First, I've got to convert these into improper fractions. So that would be 10 times 1 plus 1, 11 tenths, comma, 1/2. And 9 plus 2 is 11 ninths, comma, -1/3. Okay, and now I need to do the common denominator thing. And, what are we going to do here? So I've got 9, 3, 10, and 2. It's going to have to be 90. Yep. So I'm going to need to multiply 11 tenths by 9 ninths, 1/2 by 30 thirtieths. No, 60 sixtieths. No, wait a minute. 45 45ths. Sorry. And 11 ninths by 10 tenths. And then negative 1/3, I'm going to need to multiply by 30 thirtieths. Ugh. This is the ugly one. All right, so 11 tenths by 9 ninths is going to be 99 90ths. And then 1/2 times 45 45ths will be 45 90ths. All right, next fraction, 11 ninths times 10 tenths is going to be 110 90ths. And negative 1/3 times 30 30ths is going to be negative 30 90ths. God, hope we did all that correctly. So now I can plug in my numbers after I label them. This is x1, y1, x2, y2. And boy, does that look frightening. Well, we'll see where we get with it. If you have a haunting sense of trepidation embarking upon this journey, please know that I do too. All right, so here we go. We're diving in. So x2 minus x1 squared, open parentheses here, 110 90ths minus 99 90ths squared plus y2 minus y1 negative 30 90ths minus 45 90ths squared. So I can do 110 minus 99, that's 11. And I can do negative 30 minus 45, that's 75, negative 75. Okay, so we'll go back in here, d equals the square root of 11 90ths squared plus negative 75 90ths all squared. So now d is equal to, and what we're going to do is put these squared terms in numerators and denominators. The square root of 11 squared over 90 squared plus negative 75 squared over 90 squared. Now d equals the square root of, and we're going to combine the fractions. So we have 11 squared plus negative 75 squared over 90 squared. And now I'm going to break up the numerator and denominator into square roots. So d equals the square root of 11 squared plus negative 75 squared over the square root of 90 squared. Okay, and so now I'm going to do two things. First, I'll turn square root of 90 squared into 90, and I'll go ahead and square 11 and square negative 75. So 11 squared is 121, and I got to do 75 times 75. So 5 times 5 is 25. 7 times 5 is 35, plus 2 is 37. 375. 5 times 7 is 35. Carry the 3. 7 times 7 is 49. Plus 3, 49, 50, 51, 52. 525. So let me double check my math. So this is 35, 3, 49, plus 3 is 52. Okay, so now 7 plus 5 is 12. Carry the 1. 3 plus 2 is 5, plus 1 is 6. And then bring down the 5. 5, 6, 2, 5. All right. So D is equal to the square root of 5,625 all over 90. So now we just have to prime factor 5,625. No problem. Thanks. I've got some room to work over here. Well, okay. I want to keep all the problem together. So this is ways, checks and balances here, or pros and cons. So I got 5, 6, 2, 5. And I want to prime factor it. I know I'll go ahead and divide by, well, let's see if it's divisible by 3. 5 plus 6 is 11, plus 2 is 13, plus 5 is 18. It is divisible by 3. I wouldn't have guessed that. So let's do 5, 6, 2, 5. I know the temptation is to divide by 5, and that would be fine, but we're going to divide by 3 first. So 3 goes into 5 once. Carry the 2. 3 goes into 26 8 times. Carry the 2. 3 goes into 22 7 times. Carry the 1. 3 goes into 15 5 times. Oh my God. So 3 times 1,875. So 1 plus 8 is 9, plus 7 is 16, plus 5 is 21. So this is also divisible by 3. So now I need to do 1,875 divided by 3. So 3 goes into 18 6 times. 3 goes into 7 2 times, carry the 1. And 3 goes into 15 5 times. All right, so now I've got 3 times 625. Let's see, 6 plus 2 is 8, plus 5 is 13. That's not divisible by 3, so now I can divide by 5. All right, so we know 625 is divisible by 5, but what is it? 5 goes into 6 once, 5 goes into 12 twice, 5 goes into 25 5 times. So 5 times 125. Keep breaking it down by 5 here, and that's 5 times 25. And 25 is 5 times 5. Now I feel confident that this is what the problem wanted us to do. So we'll circle our pairs. Here's a pair, here's a pair, and here's a pair. All right, so this is really 3 squared, 5 squared, and 5 squared. So I'll rewrite 5,625 like this. D equals as the product of the squares of the factors. So instead of square root 5,625, I'll write square root of 3 squared times 5 squared times 5 squared, all over 90. Well, we can apply our knowledge now that we can break these square roots up like this. D is equal to the square root of 3 squared times the square root of 5 squared times the square root of 5 squared, all over 90. And we know that the square root of a number squared is just the number. So D equals 3 times 5 times 5 over, and I'm going to hold off on writing 90, right? Because I'm going to break 90 down now into factors. And I'll start by doing 3. That's 3 times 30. And 30 is 5 times 6. And 6 is 2 times 3. Okay, I should have started with 2. It doesn't matter. So I'm going to rewrite 90 as the product of its prime numbers. And I'll do it in order: 2 times 3 times 3 times 5. And now I can cancel any numbers I have in common on the numerator and denominator. So I can cancel this pair of 3's and I can cancel this pair of 5's. So now this whole thing reduces down to 5 over 2 times 3, which is 5/6. Amazing. And that's not an answer choice. What do we do wrong? I'm just looking at the work, trying to see where we went wrong. Because clearly we went wrong somewhere. Did I do this right? 75 times 75. Let's see. Okay, so 75 times 75 is 5,625. And let me verify that 5,625 is in fact this. So that's 3 times 3 times 5 times 5 times 5 times 5. 5625. So we broke this down correctly. So where is the error? Where is the error? You probably see it, but I don't. Oh, I see the error. I see what we did wrong. I see what we did wrong, ladies and gentlemen. When I squared 75, I forgot to add 121 to it. I dropped that 11 squared. That's what I did. So, all right. So we need to stop at this point. This is where it went wrong. Right at this point is where it went wrong because I forgot to add in 11 squared, which is 121. I just dropped it completely. So I need to go back here to 5625 and add 121. 5 plus 1 is 6. 2 plus 2 is 4. 6 plus 1 is 7. And then we bring down the 5. So I don't need to factor 5625. I need to factor 5746. And my correcting tape is losing its mind. Okay, so this is 5746. That's what I need to factor there. Okay? So this is going to be something else. We'll see what that is here in a moment. But we got to factor 5746. So I'll do that over here. 5746. We'll break that down. First we'll divide by 2. And 5746 divided by 2. I'm going to try this other method here. I don't like this very much. It's like upside down division. 2 goes into 5 twice. Carry the 1. 2 goes into 17 8 times. Carry the 1. 2 goes into 14 7 times. 2 goes into 6 3 times. All right, so that was 2873. All right, and then the process is you just put another division bar here and keep dividing. So let's see what, if this is divisible by 3. 2 plus 8 is 10, plus 7 is 17, plus 3 is 20. So it's not divisible by 3. Maybe it's divisible by 7. Is it? No, that would be 4, 1, and then we'd run out. How about 9? 9 goes into 28 3 times. Carry the 1. 9 goes into 17 once. Carry the 8. That's 83. No, that doesn't work. Wonder if 13 is a factor. Let's make sure I did that right. That's 5746 divided by 2. Yeah, 2873. I guess we have to try 13. So 13 goes into 28 twice, and that would leave behind 2. 13 goes into 27 twice, and that would leave behind 1. And 13 goes into 13 once, 221. Wow, this is a monster. 13 times 221. So now we do 221. And what on earth could it be divisible by? So 2 plus 2 is 4, plus 1 is 5, so it's not divisible by 3. What could it be divisible by? Is it divisible by 13? I don't know. We could try it again. $13 goes into 22 once, and that leaves behind 9. So 91. How many times does 13 go into 91? 13, is it 7? What is 13 times 7? 13 times 7. Okay, so it's got to be 7, right? Because that's 21, carry the 2, yep. So it's 7. So this is breaking down now into 13 and 17. And those are all prime numbers. So this is 13 squared. And so we can rewrite 5,746 as 13 squared times 17 times 2. Okay? So we can now break this up, but not as neatly as we wanted to before. We can rewrite this as the square root of 13 squared times the square root of, and then we can multiply 17 times 2 to get 34. 34. All right, so now all over 90. And so now we can do this. Square root of 13 squared is just 13 times the square root of 34 all over 90. It's not going to be reducible. Okay, so now it's 13 square root 34 over 90. Wow, that was a monster. That was evil. If only I hadn't made that mistake right there. Okay. So that was number 6, and I am definitely going to take a break now. We still have 3 more, and it's a beating. It's a beating. Here's the work we've done so far. No, I don't want to look at it. I don't even want to look at it. We'll look at it at the end. Let me go on break here. I'll come back soon. Okay, and we are back. I've switched to water now from the coffee because we've entered the second hour of work and it's rounding 7 p.m. So I didn't put my final answer in a box over here, and that was such a hard-fought battle, I feel like I should. That was a Pyrrhic victory. Okay, so we're moving on to number 7, and just looking at these answer choices, I want to cry. But we're going to do it. I don't care. We're going to forge ahead. One wonders what horrors lie within. Okay, but it's all good. It's all fun. It's all healthy. Okay, we're just practicing here. So first I've got to convert 2 2/3 into an improper fraction. 3 times 2 is 6, plus 2 is 8. That's 8/3. So, and I'll have to find common denominators with everything, but we'll get to that one step at a time. So let me rewrite this as 8/3, comma 5/8, close parentheses, comma 3/4, comma 1, I'll put as 4/4 for now. Sure, we'll be changing it. And there's no negatives, so that's 1 plus. Pun. Okay, so now we got to find a common denominator here. And I think the lowest common denominator is going to be 24. Looking at it. Yep, I think it's going to be 24. So I'd have to multiply 8/3 by 8/8, 5/8 by 3/3, 3/4 by 6/6, and 4/4 by 6/6. So my new fractions are going to be 8/3 times 8/8, 64 thirds, or 64 24ths, comma 5/8 times 3/3 is going to be 15 24ths. Okay, and then the second fraction coordinate pair is going to be 3/4 times 6/6, which will be 18 24ths. 4/4 times 6/6 is going to be 24 24ths. Okay. So now we can proceed into the darkness together. All right. So let's label these points x1, y1, x2, y2. So now d is equal to the square root of x2 minus x1 in parentheses squared. So that'll be 18 24ths minus 64 24ths squared plus, open parentheses, y2 minus y1, 24 24ths minus 15 24ths squared. Got to fight through the exhaustion here and keep working. This is a minus sign. It got smeared. Okay, so we got common denominators everywhere. D equals the square root of 18 minus 64. You need to do that one. 64 minus 18. The result's going to be negative. And I'll borrow, make this 14. So this will be 6, and this will be 4. Negative 46. So this is negative 46 squared over 24. Okay, whoops. So this is negative 46 over 24. The whole thing is squared. Plus 24 minus 15. And that's going to be 9. So I'm getting so tired now that I'm just not sure about anything unless I do it on paper. So this is going to be 9 24ths squared. Part of the reason I'm doing this is to practice, to show students that errors happen. I guess that's an emergent property of this video. And also to just demonstrate the willpower needed to just keep fighting. You just got to keep going. So if you didn't think math was a sport and you have sat here and done all these problems, you do now. You understand that it's about fighting and grinding it out. So now we can put these squared terms everywhere. So d is equal to the square root of negative 46 squared over 24 squared plus 9 squared over 24 squared. Okay, and now we can combine these fractions. D is equal to the square root of negative 46 squared plus 9 squared all over 24 squared. Now we can split up the square roots. D is equal to the square root of negative 46 squared plus 9 squared all over the square root of 24 squared. And I know that the square root of 24 squared is just 24. I'll go ahead and figure out this 46 times 46. Six times 6 is 36. 4 times 6 is 24. Plus 3 is 27. 6 times 4 is 24. 4 times 4 is 16, plus 2 is 18. So now we add 6, and this is 11, carry the 1. 10 plus 1 is 11, carry the 1, 2. So I got 2116, and I'm not going to forget this time to add 81. So this is 7, 9, 1, 2. I'm going to have to prime factor that in a minute. I'm scared. So now D is equal to the square root of 2197 over the square root of 24 squared is just 24. Okay, and now we have to embark upon this journey. 2197 prime factored. Let's see, 2 plus 1 is 3, plus 9 is 12, plus 7 is 19. So it's not divisible by 3. Let's jump up to 7. Let's see if that works, and it does. Okay, I can just see it. So 7 goes into 21 3 times. 7 goes into 9 once. Carry the 2. 7 goes into 27. No, 7 doesn't go into 27. What am I thinking? It's not divisible by 7. Oh dear. So that means we've got to go into, I don't think it's divisible by 9, but we'll try. 9 goes into 21 twice. Carry the 3. 9 goes into 21. 9 goes into a 39 4 times. Carry the 3. No, it's not divisible by 9. So let's try 13. And if we're going to try 13, I'm going to actually do the division. 2, 1, 9, 7 divided by 13. 13 goes into 21 once, and that's 9 left over. 13 goes into 99 7 times, and that's 91, so 8 is left over. So, dear God, let's hope 13 goes into 87. So it's got to be 9. No, it's not 9. That's too many times. Maybe it isn't divisible by 13. Trying to think about it. Did I make a mistake here? 13 goes into 21 once. And what's the remainder here? It's 13. Okay, 7. 8 is the remainder, not 9. So how many times does 13 go into 89? Oh. So my brain is broken. Um, let's try this again. 13 goes into 21 one time. So I'm just absolutely losing my mind here. 21 minus 13. What is that? Okay, it is 8. So how many times does 13 go into 89? I'm going to try this again down here. 2197 divided by 13. So 13 goes into 21 one time. 1 times 13 is 13. This is 8 and 89. 13 goes into 89. And we know 7 times 13 is 91, so it goes in 6 times. 6 times 13 is, I already did that one, 78. And that is 11. So now bring down, I got to put 13 into 117. So how about 9? Because 3 times 9 is 27. Okay, so this is 13 times 9. 117. 117. Remainder 0. All right. So that would be 13 times 169. Okay. Let me just double check, but I think 169 is 13 squared. And it is. So that's 13 times 13. So 2197 is 13 cubed. Now that would be good to know. There are probably some number sense people out there who are bored out of their minds. Of course, I don't think anybody's watching this video at this point. I'm just talking to myself. So now we can write D. So I've got one pair of 13s here. That's 13 squared times 13. So D is equal to the square root of 13 squared times 13 over 24. And we can break this up into the square root of 13 squared times the square root of 13 over 24. Now what? Well, the square root of 13 squared is just 13, so it's 13 square root 13 over 24. And I'm just going to pray that that's there, because if it isn't, I'm probably going to cry. I'm putting it in a box preemptively because I am just hopeful. And there it is, letter A. Good Lord, what a nightmare. These problems are the things nightmares are made of, people. Okay, so now what? Number 8. Let's proceed. First, I've got to convert -2 1/6 into an improper fraction. And so that's 9/10, comma, that'll be 13/6, -13 over 6, comma, next pair, -3 over 2, comma, 0. Well, that's going to be interesting. We'll see what that does. I haven't worked with that one before. And so we need a common denominator. 10, 6, and 2. So I'm guessing it's going to be 30. Yep. So I'll have to multiply 9/10 by 3/3 and -13/6 by 5/5, and then -3/2 by 15/15. So here we go. 9/10 times 3/3 is going to be 27/30, comma, 13/6 times 5/5. I don't know what 13 times 5 is. 65. So this will be -65/30. And now I need to do, this will be negative 45/30ths, comma 0. All right, well, we'll just proceed. X1, Y1, X2, Y2. And we'll plug it into the formula. If anybody wonders how I passed the math certification test, this is what I did for an entire summer. I just worked like 500 problems. So D equals square root of, now we'll plug everything in. I need X2, which is negative 45/30ths, minus X1, which is 27/30ths, squared, plus Y2, which is 0, minus Y1, which is minus 65. Almost made a mistake there. Minus 65/30ths squared. All right. So minus minus is a plus. Okay. So D is equal to the square root of negative 45 minus 27. So we add 45 and 27, and the result will be negative 72. So I've got negative 72 over 30 squared plus, and 0 plus, it's 0 is just 0. So this is just 65 over 30 squared. Well, now I can combine the fractions because I have common denominator. Negative 72 squared plus 65 squared over 30 squared. All right. And now I can break it up into square roots on top and bottom. It's negative 72 squared plus 65 squared all over the square root of 30 squared. Of course, the square root of 30 squared is just 30. So now I better find out what 72 squared is. 72 times 72. 2 times 2 is 4. 7 times 2 is 14. 2 times 7 is 14. 7 times 7 is 49, 50. So 4, 8, 1, and 5. 5, 1, 8, 4. That's 72 squared. And now I got to do 65 squared, and don't forget to add them together. 5 times 5 is 25. 6 times 5 is 30 plus 2 is 32. 5 times 6 is 30. 6 times 6 is 36 plus 3 is 39. So we got 5, 2, 12, and 4, 4, 2, 2, 5. So now I need to add 4, 2, 2, 5 to 5, 1, 8, 4. That's 9, 10, carry the 1, 4, and 9. 9, 4, 0, 9. Good Lord. So D is equal to the square root of 9,409 all over 30. So now I just have to prime factor 9,409. It's just absurd. 9,409. Let's prime factor this guy right here. Well, let's see if it's divisible by 3. 9 plus 4 is 13. 13 plus 9 is 22. So it's not divisible by 3. Let's see if it's divisible by, it's going to be a big number. See if it's divisible by 13. I'll do it over here. 9,409 by 13. 13 goes into 94. What do we learn from that other problem? 7 times? Because that's 91, right? 91. I don't even know if this is going to work. Okay. 13 goes into 30 twice. That's 26. And I don't think it's going to work because this is 49. And 13 times 3 is 39, not 49. So this didn't work. So 13 is not a factor. It's not 15. I'm going to jump up and try 17. I don't know any of the factors of 17 or multiples, so 9,409 by 17 makes me wish I would have memorized them all. All right, so how many times does 17 go into 94? Because I don't even know. Let's see. 17 is close to 20, and 20 times 5 is 100. So let's try 17 times 5 and see if we get close. That's 35, 85. That's as close as I'm going to get. So the first number is a 5, and that's 85. Right, so $90. Again, it's going to be a 5. And this is going to be 85. 59. So is 17 a factor of 59? I don't know. Trying to think of anything times 7 that equals a 9 other than 7. I don't know. Let's see here. I don't think there are any. So 17 is not a factor. 9,409. What could the factor be? It's got to be something big. Oh, let me make sure I did this correctly here. 72 times 72. Okay, 5184 looks right. 65 times 65. 4225. Let's make sure I added right. 9409. It's got a factor. What could it be? What could it be? All right, well, I'm just absolutely stuffed here. What did we try already? We tried, it's not 3, this is 9 plus 4 is 13 plus 9. That's 22. It doesn't work. It's not 7. It's not 9. Is it? That won't work. I'm going to need a factor. Oh. It's got a factor. It's got to factor. I'll tell you what. I'm looking for something. Used to have a little tiny calculator somewhere. I don't know where it is now. I'm going to violate my own oath. So we're going to do something here. We're going to call in this guy. And we are going to try numbers here. So 9409 divided by, just double check everything, 13. No. 9409 divided by 14. No. 9409 divided by 17. No. 9409 divided by 16. No. 9409 divided by 19. No. 9409 divided by 21. No. 9409 divided by 23. No. 9409 divided by 20. 7. No. 9, 4 divided by 29. No. 9409 divided by 31. No. Divided by 39. No. 9409 divided by 37. No. 9409 divided by 41. Whoa. No. 9409 divided by 43. No. What could it be? I already did that one. 949 divided by 9409 divided by 53. 9409 divided by 57. 9409 divided by 59. Oops. No, this is just becoming. It's not gonna. Let's make sure I didn't do something crucial wrong up here. 9/10. Okay, turn that into 27/30. I did this. 2 times 6 is 12 plus 1 is 13. And then I did 13 times 5. 65, that was correct. 3 times, yeah. Hang on. Okay. This, I just checked it on Wolfram. 9409. You're not going to believe this. I mean, we never would have got that. We would have eventually. 97 times 97. That's what it factors into. And 97 is prime. So what does that mean? That means that this goes to D equals the square root of 97 squared over 30. And that equals 97 over 30. Okay, and so we got to express it as a mixed fraction. 30 goes into 97 3 times with 7/30ths as a remainder. I don't know if that's the hardest problem I've ever done, but that was absurd. That was absurd. That was brutal. because, I mean, who would have known, right? Who would have known it was 97 squared? You know, from the perspective of pencil and paper math, you know, I tried the phone, tried just using a basic 4-function calculator, and then I gave up on that, and I had to hit the big guns, and I used WolframAlpha to factor it, and that's just the fact that that would even come up as a problem. That would make me angry. You know, if I had a problem like that as a student, and so as a teacher, I got to make sure that I don't ever use that problem. And I'll have to put that one away as don't ever use it, because that was just a dirty, rotten problem right there. So, you know, we spent 44 minutes on 2 problems, but we did get the answers, so that's one thing. So for the one lunatic who's still watching me, I don't know that there are any. We're going to take another break and then come back and try these. And I'm telling you guys, just look at this. Okay, so there's some darkness still on the horizon. But we'll take a break and come back and try again. Try to finish these off. I knew this was going to be hard. I didn't know it was going to be this hard. I'm right now, I mean, I'm shaking. I'm so tired. My brain no longer functions as an organ, and I'm going to go like lay down and just count. I don't even know if I'm going to count. I don't want anything to do with numbers. I think I'm just going to drink this water and lay down and try to think about like living on an island somewhere like Fiji or Kauai or the Seychelles or some little like Easter Island, some abandoned island, or it's not abandoned, some island in the middle of the Pacific Ocean. Okay, I will be back soon. Okay, and we are back. We are back for the final two. We are about to round the 3-hour mark. 2 hours and 53 minutes so far in this video. I'm out of water. Not good. I'm not going to drink the rest of this coffee or I'll be up all night. So we're just going to plow ahead. Or as the English say, we're going to crack on. All right, so we're going to do these last two problems. And they look like they're really hard, but maybe they're not. We'll see. We will see, won't we? Okay, so the first thing we got to do here is, look how innocent this looks. It just looks like, well, but we're going to convert these to improper fractions. So this will be -2. I guess I better put them in terms of 2, right? So these should be -4/2, comma, 4/2. And this will be -3/2. So I should put that as -6/4. And then 5/2 should be 10/4. Well, at least we got our, oops, wait a minute. Need to make this with a 4 in the denominator, don't I? No, I don't. I didn't need to write that. I didn't need to rewrite that. They already had a denominator of 2. I don't know what I'm thinking. I know what I'm thinking. I'm exhausted. That's what I'm thinking. So this is -4/2 and 4/2. Okay, so we have common denominator with 2. So this is x1, y1, x2, y2. Okay, this is starting to feel like some kind of medieval torture, but we're going to continue. Okay, this is descended or ascended, depending on your view of it, from a level of dedication to one of obsession. We're just going to finish. All right, so this is x2 minus x1, so that would be -4/2. Minus -4/2 squared plus y2 minus y1, 4/2. Now that can't be right, can it? Yeah, it's not right. This is 5/2. Yeah, sorry. So this should be 4/2. This should be 5/2. Wait a minute. Yeah, this should be 5/2 minus 4/2. Squared. I just want to check this. This is x2 minus x1, y2 minus y1. Okay. So this is a plus. And now we've got d equals. All right, so we've got here, is this right? 0? I mean, this looks like 0 over 2 squared, which would just be 0. All right, we'll see. Plus, and then 5 minus 4 is 1, 1/2 squared. If that's right, and it might be wrong, and you might be seeing it, we'll find out. Right now I'm looking at D, because 0 divided by anything is 0, so I'm looking at D equals the square root of 1/2 squared, which is equal to just the square root of 1 squared over the square root of 2 squared. This just can't be right, because that would mean that this is 1/2, and that's not an answer choice. So what did I do wrong? All right, so this is negative 4 over 2, and this is 4 over 2, and this is, that's the mistake right there. This was not 4 over 2, it was negative 3 over 2. It's just exhausted. Should have been negative 3. So x2 should have been negative 3. And that would make this that would make this 1. Okay. And that means that this was wrong. Oh no. This is all wrong. And the correcting tape is jammed. It's been overused. Okay, we'll just get rid of this and try a new line. So D is equal to the square root of 1 squared plus 1 squared over 2 squared. All right, I see that now. I see the solution. This is going to be equal to the square root of 2 over the square root of 2 squared, which is just the square root of 2 over 2. Okay. That was number 9. And number 10. There's nothing to convert here, but I do need to find a common denominator. 7, 6, and 4. I'll just multiply them together. It's going to be 42 times 4 168. There's got to be a smaller one. Let's just list out the multiples of 7. That's 14, 21, 28, 35, 42, 49, 56, 63. Oh, it's got to be 84. Please tell me 84 divided by 6 is something. Yeah. 14. Yep. Okay, so it's going to be 84. So I need to multiply here. 84 is going to be the denominator here. So that means I need to multiply 3 times 12, and that'll be 36 over 84. Okay, comma 0. That's a blessing. And 6 times 14 is going to be 14 84ths, comma, and then 4 will go into 84 21 times. So that'll be 21 84ths. And let's double check that. 21 times 4, yeah, 84. Okay? So now we can set up our distance formula here. Distance equals the square root of x2, we got to label x1, y1, x2, y2. And x2, so open parentheses, 14 over 84 minus x1, 36 over 84 squared plus y2 minus y1. y1 is 0, so that's just 21 over 84 squared. Okay, so 14 minus 36, that'll be 36 minus 14, the result being negative, and that is 22. So now D equals the square root of negative 22 over 84 squared plus 21 over 84 squared. Okay? All right, here we go. So that means D is equal to the square root of negative 22 squared plus 21 squared over, and then the square root of 84 squared is just 84. All right, so now I got to do 22 times 22. $44, $44, 484, 484, and 21, 21. That'll be 441. Now I got to add 441 to 484. 925. So that means that D is equal to the square root of 925 over 84. And I'm happy about that because I know 925 is divisible by 5. Five goes into 9 one time with 4 as a remainder. 5 goes into 42 8 times with 2 as a remainder. 5 goes into 25 5 times with no remainder. So if I'm breaking down 925, factoring it, I got 5 times 185. And I know that's divisible by 5. So we'll divide by 5 again. 5 goes into 18 3 times with 3 as a remainder. 5 goes into 35 7 times. So 5 times 37. Okay, we're still in business. So I've got a pair of 5s here. So that means this is 5 squared. So D is equal to the square root of 5 squared times the square root of 37, all over 84. And that is equal to 5 square root 37 over 84. We'll put that in a box and check. There it is. That one wasn't that hard. Okay, so it's at 3 hours and 10 minutes now. We have completed the 10 problems. Many riddled with errors, many errors, stupid errors. And one very difficult, factoring into 97 squared. So here we are. And what have we learned? Well, I think we've learned that I make very stupid errors. Also, we've learned that working tired means you're going to make little clerical mistakes and forget things. What else have we learned? We've learned a lot about how the distance formula works and breaking down the process of breaking down those squares and the square roots and factoring and the kind of the process of all that and kind of what we're doing. And we've also learned that dedication sometimes spills over into a kind of maniacal focus and obsession on just finishing a task. And so those are complete. And now I suppose we should check the answers. It's the first time I'm seeing this. So 1 is C. Let's grade ourselves. All right, so that's correct. 2 is A. That's correct. 3 is C, and 4 is C. 5 is D. 6 is A. 7 is A. 8 is D. 9 is C. And 10 is B. Well, it's one small silver lining is that we made 100. And honestly, that feels pretty good. Was not without a fight, and we only had to resort to a calculator one time for that 97 squared. Where was that at? Here in problem 8. I don't know that I ever would have gotten that. I could have just kept trying with the calculator, but if I had tried to do it on paper, that would have taken all night. So we will end this video. I'm to say, well, are we glad we took the journey? I don't know, but I tell you what I learned. I learned a lot about multiples of 13. I hadn't worked with 13. You don't work with 13 very often, multiples of it, and just you got to stay focused on putting everything in the right place, or you'll run through a whole roll of this liquid paper stuff. So we'll stop it there and end the video here at 3 hours and 14 minutes and 37 seconds. It's going to be over 3:15 when we're done. Here we are, folks. 10 distance formula with fractions problems, fully solved. Okay, almost entirely by hand. And I am done. All right, if you are still watching this, I feel like you deserve the thumbs up. But give this video a thumbs up. If anything about this video was redeeming in the slightest sense, because I need the boost in morale at this point. And thank you very much for watching. We've got to keep practicing this because distance formula with fractions is so much harder than distance formula with integers, as you now know. So thank you, and please remember to subscribe to the channel and hit that notification bell so you are always alerted to new videos on this channel. Thanks.